All right, welcome back, class. This is now Unit 9, Exponential and Log Functions. So, 9.1a will be Exponential Graphing. And the I-CAN statements are: we can graph exponential functions, identify asymptotes, domain, and range, and then identify if it's exponential. This would be growth or decay here. So this is the standard form of the exponential function. We have a vertical and horizontal shift again, which is our HK. And then A will do the same where it's vertical stretch or vertical shrink. If B, the absolute value of B, is greater than 1, then it's exponential growth. And that has to do with like viruses, or really applicable to how the virus of COVID-19 spread. It's exponentially growing, and that was at the beginning last March. And then like the reverse then would be exponential decay, would be like the depreciation of your car. The value of your car will exponentially decay. So it really quickly will decay or deteriorate. So, and then again, asymptotes. So in both cases here, there's an asymptote at the line y equals 0. The function in both cases will never pass that point. It'll approach it forever. And so that's the asymptote. And we will go through some examples to see how to graph our functions. And another thing, if a is negative, if we have a negative leading coefficient, then it's a reflection across the x-axis. So a lot of familiar concepts here. So let's look at this first example then. Our standard form is a times b to the x minus h plus k. So in this case, we have an implied leading coefficient of 1 for our a value. And then our b is 2. And since, I'm going to rewrite that, since 2 is greater than 1, we call it a growth. And that's because b equals 2, which is greater than 1. It's going to grow really fast. If it was less than 1, then it would shrink really fast. So now we want some nice input values, and each time we're going to input -2, -1, 0, 1, and 2. And in our function here, we're plugging that in for x. So now our output, f of x, will be 2 to the -2 power, because I plugged in -2 in for x. So this goes back to Unit 8, properties of exponents. Because it's a negative exponent, we want to take the reciprocal. So now it's a half squared. And when you distribute that to the top and the bottom, that's 1 squared over 2 squared, which is just a fourth. And then you do the same now for 2 to the -1 power. So that'd be half to the first, which is just half. Anything to the 0th power, I'll just show you, is 1. So that would be 1. And then you have 2 to the first power, which is 2, and then 2 squared. So that's 2, and then that's 4. This last column is similar to Unit 8. It is for our AY, but we will not be scaling it by a different factor because it's 1, A is 1, so it would be the same output here. So we can disregard this column for this example. And then there is no HK associated, so there is no shift for our function, so it does start at 0, 0. And then we can plot our points. So -2 fourth, so 1, 2, and then a fourth. And then -1 half, 0, 1. Hopefully pretty quickly you can see that it's going to be growth. 1, 2, 2, 1, 2, 3, 4. And it grows really quickly. And that's what happens with exponential functions. And again, it approaches this asymptote here. It never crosses it, but it approaches it. My domain, it will continue left and right forever. So that would be x is an element of all real numbers. My range will be indicated by my k. So just like with square root functions, here it's 0, so y is greater than 0 because it will never cross this line or touch this line. It's strictly greater than, and then my asymptote is that line, y equals 0, which is the line y equals k. So whatever k is, that's your asymptote here. All right, so let's look at this next problem. Now we have a negative leading coefficient, so a equals -2. So that'll be a reflection across the x-axis. And my b, again, is greater than 1. B equals 2. So we already know it's going to be a growth, but it's going to be negative. So not a growth this way, it'll be a growth down this way because it's a negative leading coefficient. And then we want those same input values. So -2, -1, 0, 1, and 2. And our b, in this case, is going to be the same as the last one. So my output will be the same thing, but I'm just going to show you for this first one at the very least, just to see the practice. It's 2, because that's my b, raised to the x power. And in this first case, x is -2. So then when we take the reciprocal, we now have a positive exponent. And when we distribute our exponent to the top and the bottom, that becomes 1 squared over 2 squared, which is 1/4. And then we follow through with the rest of our outputs. Then it was a half. Anything raised to the 0th power is 1. And then we have 2 to the first power, which is 2, and then 2 squared is 4. Now, for our third column, ay, we do have a factor other than 1 that will scale it. So we're going to multiply -2 times y, and we can rewrite y as f of x. It's the same thing, it's just our output. So we're going to multiply by -2 for each of these for our new output times -2. So this would be -1/2. This would be -1, -2, -4, and -8. So it is going to be a reflection across the x-axis and a vertical stretch because a is greater than 1. Our shift, again, there is no h and k. So our shift is going to be 0, 0. We said it's a growth. Now let's plot these new points. So it looks like -2, -1/2, -1, -1, 0, -2, 1, 1, 2, 3, 4, and then 2, -8, which should be right here. So really quickly growing, and then approaching the asymptote. It's not going to cross that line. It's just approaching this asymptote. So the domain, again, it's going to continue left and right forever. So x is an element of all reals. Y is now less than. If we look at our y values, it's decreasing and starting at a height close to 0. So it's strictly less than 0, and our asymptote, the line is y equals 0. And that's how we go about graphing these functions. Okay, now we do have a shift, and also b is less than 1. B is this value, so b equals 1/2, which is less than 1. Because it is less than 1, that implies decay. So it's going to start up here because it's also positive and slowly approach our line. And our shift, there's no h associated to x. And just like with our square roots or cubed roots, our k value, the sign will stay the same. The h sign will be the inverse because it's x minus h. K will stay the same, however. So our shift is going to be 0, 2, and we can call that our new origin again. And this is where we are plotting from. So 0, 2, and then I'm going to draw my new x and y lines here through, just to be clear that that's where our new origin is. Inputs, we want the same inputs, -2, -1, 0, 1, and 2. And then we're now taking half to that power, these powers of x. So let's do the first one. It's half to the -2 power. So we take the reciprocal, so now it's 2 over 1, or just 2 squared, and that's 4. Then we have half to the -1st power, so that's 2 to the 1st. Anything to the 0th power is 1. Then we have half to the 1st, so that is just half, and then half squared. Now is where you can see some good practice of, if it's a quotient, you distribute to the top and the bottom. So 1 squared over 2 squared is 1 over 4, 1/4. And are we going to scale it by anything? In this case, it's an implied coefficient of 1. So my a equals 1. So again, my AY column, there will be no change. But we do have input-output values based off our new origin. Not the origin, we shifted. So from our new origin, we're going to go back 2 and up 4. So 1, 2, and then 1, 2, 3, 4. And let's see if we start to get closer and closer to our asymptote, because if it's less than 1, it should be a decay. -1, 2, 0, 1, 1/2, and then 2/4. It does. It approaches this line because it's slowly decaying. And actually, it's quickly decaying. It's a really quick factor. So my domain, it's left and right forever. So x is an element of all reals. And then my range, my y values are greater than, and we're looking at our k value, which is 2. And you can also verify on the graph, this is a height of 2, and it's approaching that height. So that is also my asymptote, y equals 2. All right. Okay, so we have a lot of movement here. We have an a value, b is less than 1, and we have an h. Cool. So let's start with my a. My a is a positive value of 2. So it's not a reflection. It's greater than 1, so it's a vertical stretch. My b is 1/3. So because it's less than 1, it's a decay. And my shift, we do the opposite for h because it's x minus h. So this will be a +3, and there is no k. There's a +0. That would be my k. So it's 3, 0. So let's do my shift first. 1, 2, 3, and then up 0. So that's my shift. Input values the same. -2, -1, 0, 1, and 2. We're raising b to that power, so it's 1/3 to the -2, so we must take the reciprocal. So that's 3 squared, which is 9. 1/3 to the -1st power equals 3 to the 1st power, so that's just 3. Anything to the 0th power is 1. Anything to the 1st power is itself, so 1/3 to the 1st is 1/3. And then 1/3 squared equals 1/9, because it'd be 1 squared over 3 squared, so 1/9. Now we must scale it by whatever our a is. A is 2, So we're scaling all of our output values, f of x, or 2 times y, and we're factoring it by, or scaling it by a factor of 2. So 2 times 9 is 18, 3 times 2 is 6, 2, this is 2/3, and then 2/9. So we can get rid of those outputs. These are our new outputs, and we're graphing from our new origin. So our first ordered pair is -2, 18. So that's way off the graph. So let's go to the next one. It's -1, 6. So -1, 1, 2, 3, 4, 5, 6. 0, 2, 1, 2/3. Again, it's a decay here, so it's going to get or approach our asymptote. And then 2, 2/9. So really quickly goes up here and then approaches this line. Domain, x is an element of all reals, and our range, y is greater than 0. Our k is 0, and that's also our asymptote. How many more do we have here? All right, let's do this one. I like that it'll be a reflection because we have a negative leading coefficient. So a equals -2, b equals 1/3. Because it is less than 1, again it is a decay, and my hk is however it shifts. We do the opposite for h, so that's -1, -3. That is my new origin, and we can plot that. -1, 1, 2, 3. I like to put my dashed lines here just so I can remind myself that that's where we will be plotting from for a new origin. And then we can put our input and output values. -2, -1, 0, 1, and 2. And again, it is 1/3. So for my first column of outputs, it's the same here, because we have 1/3 to these powers. So it'll be 9, 3, 9, 3, 1, 1/3, and 1/9. What will change now is my new outputs, because of the factor is different. It's a -2, so it'll be a reflection. These values will now become negative. So -18, I'm multiplying -2 by my f of x column. Y is f of x. -6, -2 times 1 is -2. -2/9, excuse me, -2/3, and then -2/9. We can get rid of this, and now we can plot our new ordered pair. -2, -18, again, that'd be way down here. -1, -6, 1, 2, 3, 4, 5, 6. 0, -2, 1, -2/3, and then 2, -2/9. So that's getting real close. We're approaching. There we go. X is an element of all reals, and then y, our indicator, is our k value. And is it greater than or less than? Well, let's verify with the graph. They're decreasing values, so it's going to be less than -3, and that is my asymptote at my k value, which is -3. Yeah, let's do this one just for extra practice. So my A is going to be 2, B is 3, so now this time B is a growth factor because it's greater than 1. And my vertical and horizontal shift, we do opposite of H, so that would be 2, 1. That's my new origin. I'm going to put that on the graph, 1, 2, 1. And then this is my xy here. Good. And then my input values, -2, -1, 0, 1, and 2. So, and again, if you're watching this video and you want to try output and then the scaled factors, do that and then play the video and see if we get the same values. That would be good practice. I probably should have said that earlier in the video. So now it's my b value, 3, raised to these values. So we have to take the reciprocal. So that's 1/9. We know we'll have to take the reciprocal for the second one because it's also negative. So I can just go right here. 1/3 to the first is 1/3. Anything to the 0th power is 1, 3, and then 9. And then my a is, how would I put f of x, just to be clear on this one? It's a times f of x. A equals 2. So 2 times my f of x. So it's 2/9, 2/3, 2, 6, and then 18. And then we can get rid of this column. So from my new origin, we're going back to up 2/9. 1, 2, up 2/9. -1, 2/3. It's a growth factor, so it should be growing. 0, 2, 1, 1, 2, 3, 4, 5, 6. And then 2/18 is really huge, so I'm just going to approach it here. And then this approaches the line. X is an element of all real numbers. Y is now greater than. It's increasing. Whatever our k is, it's 1. Let's confirm it on the graph. It is a height of 1. And that's our asymptote here. Y equals 1. All right, thanks for watching. Let me know if you have any questions, and I'll see you later. Okay, bye.